If you ask someone to name a dwarf planet, the most famous and first one that comes to mind would be Pluto. Since its identification by astronomer Clyde Tombaugh in 1930, Pluto has been demoted from a classic planet to its dwarf state. But it wasn't until 2006 that it was downgraded from a classic planet to its dwarf status. However, not everyone is aware that it is not the first planet to be reclassified. Ceres, a 940-kilometer wide dwarf planet that has been shown to be an excellent cryogenic puncher, takes the prize. Vesta is the second largest asteroid in the belt, with only Ceres being larger. So in today's video, we'll be looking at Ceres and Vesta. Stick around till the end of the video to discover what Don helped us discover about Ceres and Vesta. Stay tuned. Vesta, the brightest asteroid in the sky, is occasionally seen with the naked eye from Earth. It is the first of the four biggest asteroids to be explored by a spacecraft: Ceres, Vesta, Pallas, and Hygiea. It is known as 4 Vesta since it is the fourth asteroid found. In Roman mythology, Vesta is the goddess of the home and hearth. Carl Friedrich Gauss, a German mathematician, was the one who named the asteroid. He was awarded the distinction of being named Vesta because of his contribution to the discovery of the celestial object. Another reason he named it was because he was given the honor by Heinrich Olbers, a German astronomer who had already named and found Pallas and Ceres in 1801-02, celestial police. While calculating the elliptical form of planetary orbit in 1596, Johannes Kepler concluded that there should be a planet between Mars and Jupiter. In 1772, Johann Daniel Titius and Johann Elert Bode calculated the Titius-Bode law, eventually known as the Titius-Bode law. An organization known as the Celestial Police was founded in August 1798 to look for this missing planet. Heinrich Olbers, a German astronomer, was one of them. Pallas, the second known asteroid, was found by Olbers. In a letter to a colleague astronomer, he proposed the initial idea of asteroid genesis. Could it be that Ceres and Pallas were merely two shards of a once bigger planet that previously occupied its natural location between Mars and Jupiter, he wondered. According to Olbers, the components of such a planet would cross at the location of the explosion and then again in the orbit directly opposite. He kept a nightly eye on these two regions and discovered Vesta on March 29, 1807, making him the first person to find two asteroids. Olbers transmitted his calculations to mathematician Carl Friedrich Gauss, who miraculously predicted Pallas's orbit in under 10 hours after measuring many nights' worth of observations. Formation: Vesta originated soon after the solar system was born, around 1 to 2 million years later. As a result, the celestial object seems to have a crust, mantle, and core that are remarkably similar to those of our planet. As a result, it is distinguished from other asteroids. This is due to the asteroid's early development. Short-lived radioactive elements were absorbed into bodies during that epoch's formation, and they were overheated to the point that things melted, allowing heavier particles to sink to the asteroid's core, and lower-density materials to rise. Vesta's core accreted quickly, within the first 10 million years of the solar system's creation. Vesta's basaltic crust developed fast over the span of a few million years. Volcanic eruptions on the surface, which lasted anywhere from 8 to 60 hours, were caused by the mantle. The lava flows were 100 meters long to several kilometers long, with a thickness of 5 to 20 meters. The lava cooled quickly before being covered by fresh lava until the crust was complete. Dawn's gravity pushed its core to be around 18% of Vesta's mass, or almost 2/3 as large as Earth's core. If it hadn't been for Jupiter, Vesta could have had a decent chance of becoming a planet. Physical characteristics of Vesta. Vesta has an asymmetrical form, resembling an oblate spheroid. On its surface, a massive crater with a diameter of 460 kilometers, 285 miles, has been discovered. The entire asteroid is barely 530 kilometers, 329 miles across. It slices roughly 13 kilometers, 8 miles, through the Earth's crust, implying that it originated as a result of a violent impact. The debris thrown from Vesta created tiny vestoids, asteroids orbiting close to their parent, some of which landed on Earth as meteorites as a result of the impact. Vesta is the only asteroid with bright and dark regions on its surface, similar to the Moon. According to ground-based investigations, the asteroid features basaltic areas, indicating that lava once flowed over its surface. It's irregular in form, like an oblate spheroid. Orbit and rotation. Vesta circles the Sun within the asteroid belt every 3.6 years. Notably in the inner asteroid belt, internal to the Kirkwood Gap at 2.50 AU, between Mars and Jupiter. Vesta has a 7.1 degree inclination to its orbit, as well as an eccentricity of 0.09, which is identical to Mars. Vesta has the ability to temporarily catch other asteroids into 1-to-1 resonant orbital partnerships for periods of up to 2 million years. So far, 40 such partnerships have been discovered. Ceres. It was the world's first asteroid discovery. Piazzi named his discovery Ceres after the Roman goddess of harvest and corn. According to the Encyclopedia Britannica, she was also the patron goddess of Sicily. When he discovered this missing planet, Piazzi mistook the new moving star for a comet. He watched its slow and very consistent movement, a total of 24 times before concluding that it wasn't one. The minor planet Cerium was given its name in 1803, and the element cerium was named after it. According to Wikipedia, cerium is the most plentiful of the rare earth metals, and it may be found as a fission product of plutonium, thorium, and uranium, among other things. The Sicilian astronomer Giuseppe Piazzi discovered Ceres on January 1, 1801. After Piazzi followed up on mathematical predictions that there should be a planet between Mars and Jupiter, the asteroid was discovered. Ceres was originally classified as a planet, but when more asteroid belt members were discovered, Ceres was reclassified as an asteroid. As stated earlier in the video, it was demoted from a full-fledged planet to a dwarf planet in 2006, a designation it shares with Pluto, which was demoted from a full-fledged planet in the same year, and a move that is still being debated today. Formation. Ceres is a little under 2.8 astronomical units from the Sun, so it receives its light in about 22 minutes, and it is about 3.5 astronomical units from Earth, so light from Ceres takes 29 minutes to reach us. Within Neptune's orbit, it is the 33rd biggest body in the solar system. Ceres is thought to have originated some 4.5 billion years ago. During the formation of the solar system, gravity drew a whirling gas and dust together, eventually forming the tiny dwarf planet. Ceres is classified as an embryonic planet, or protoplanet by scientists, implying that it began to develop as a planet, but did not complete the process. Instead, Ceres settled into its current place, among the remainder of the planetary formation's remaining parts. Another hypothesis says that Ceres may have evolved within the Kuiper belt, before moving closer to the Sun due to several enormous gravitational effects. Size. It's about the same size as France. Ceres is a giant among asteroids, or former asteroids that have subsequently been promoted to dwarf planets. It could easily span the entirety of France, with an average diameter of roughly 950 kilometers, 590 miles. Unlike the other asteroid belt members, Ceres is spherical, since it is massive enough for gravity to mold it into a sphere. Round bodies, according to scientists, have distinct interiors, implying that there are different zones within them. Ceres has a rocky core, an ice mantle, maybe some liquid water beneath the surface, and a dusty top layer. Physical characteristics of Ceres. Ceres resembles the terrestrial planets more than its asteroid companions, Mercury, Venus, Earth, and Mars, yet it is far less dense. A stratified interior is one of the similarities, but Ceres' layers aren't as well defined. Ceres most likely has a solid core and a water-ice mantle. Ceres, in fact, might be made up of as much as 25% water. Ceres, if this is right, contains more water than Earth. Ceres has a rough, dusty surface with significant salt deposits. The salts on Ceres aren't formed from table salt, but from other minerals like magnesium sulfate. Ceres' atmosphere is extremely thin, and there is evidence that it includes water vapor. Ice volcanoes or sublimating ice near the surface might create vapor, transforming from solid to gas. Astronomers think Ceres' surface temperatures might reach negative 37 degrees Fahrenheit, minus 38 degrees Celsius. Despite its distance from the Sun, its makeup is conducive to the emergence of life as we know it. Its chances of surviving are bright, and as a result, it has piqued our interest for future investigation. Any water ice on the surface will swiftly sublimate, turn into gas, creating an atmosphere around the dwarf planet. Yet, however, there have only been a few reports of potential sublimation. Dawn will keep her eyes peeled for more. Orbit and rotation. It travels between Mars and Jupiter, passing through the asteroid belt and getting closer to Mars' orbit. The orbit is moderately inclined, 1 equals 10.6 degrees, compared to 7 degrees for Mercury and 17 degrees for Pluto. A moderately eccentric, E equals 0.08 degrees, compared to 0.09 degrees for Mars. It takes around 4.6 Earth years, or 1,681 Earth days, to complete one orbit around the Sun. Ceres completes one spin every 9 hours as it circles the Sun, giving it one of the shortest day lengths in the solar system. Dawn. When it arrived at Vesta, the second largest world in the main asteroid belt, in 2011, Dawn became the first spacecraft to circle a body in the zone between Mars and Jupiter when it arrived at Vesta. In 2015, Dawn became the first mission to visit a dwarf planet and travel into orbit around 2 locations beyond Earth, when it entered orbit around Ceres, which is also the biggest world in the asteroid belt. Dawn demonstrated the importance of location in the formation and evolution of objects in the early solar system, among other things. Dawn also supported the theory that dwarf planets might have had, and possibly still do, harbor seas for long periods of time. The Dawn spacecraft also sent back images of the strange bright spots that dot the dwarf planet Ceres' surface. Perplexing spots, which were discovered inside a 55-mile wide crater, are now resolved into a cluster made up of numerous patches, some of which were not seen in prior images. However, it does not provide an answer to the question of the spot's origin and composition. What are your thoughts on Vesta and Ceres? Would you relocate planets if it was announced in the future that humans could survive on Vesta and Ceres? Let us know your thoughts in the comment section below.